Okay, good morning. My name is Ali, and I'm a teaching fellow with Delta Analytics. I'd like to briefly introduce our organization. The mission of Delta is to increase access and usefulness of data to empower change makers to better their communities. We accomplish this through our two core programs, the first of which is the Data Science Grant, where we bring together not-for-profits and skilled data professionals on project opportunities in order to accelerate their impact. We also have the Machine Learning for Good program, the Teaching Fellows program, where we empower anyone anywhere to leverage data for good in their communities by building technical capacity around the world. We have been around since 2013 and have so far completed 50 projects with not-for-profits and social impact organizations. We have also open sourced and taught our machine learning curriculum to students globally. We have donated over 20,000 hours and recruited about 200 professionals to work on projects and have charged $0 for our services. Delta has been working since 2013 to help not-for-profits around the world. In 2017, we started the Teaching Fellows program. There's the timeline for our key initiatives. In 2017, we built our curriculum from scratch and taught our pilot program in Nairobi, Kenya. In 2018, we beta tested, revised, and open sourced our curriculum. We taught subsequent classes in Morocco and the SF Bay Area. In 2019, we exploring our curriculum with active learning techniques. And now 2020, we are going global for the first time. Our goal is to support educators all around the world. Here are our Bay Area Teaching Fellows and our Global Teaching Fellows, whose Machine Learning Virtual Talks lecture series you've been following on YouTube. Now it's my pleasure to introduce Chima for today's lecture on decision trees.
Hello, everybody. Today we'll be talking about decision trees. My name is Chima Ibebunjoh. I'm an urban planner and GIS analyst. Anytime you think of location, you think about Chima. And currently, I work at Turntable, and I'm a global teaching fellow for 2020 in Delta Analytics, and I love cycling. The agenda for today would go like this. First of all, we'll talk about the housing price generally, and also Lagos in specific. And we'll talk about what is decision tree, the advantages and the disadvantages. And we'll also see some real life applications. And then we'll talk about the components of decision trees, how decision trees work, and we'll do a small demo using the Lagos housing data sets. And at the end, we'll do a small check for understand. That's the Q&A session. Okay, housing price. There are three images on your screen, A, B, and C. Could anybody tell me which of these houses you think is the most expensive? Okay, most people say C. The right answer for this question is actually, it depends. It depends on various factors, not just the size of the house. Buying a house is actually a lot of work, and buyers are unaware of the factors that affects housing prices. So it brings this question: does the housing price only depend on the number of bedrooms, the location, or whether it's in a gated neighborhood or not. Although these other features matter, the amenities, number of toilets, the age of the building, whether it's in an estate or not. Lagos, Nigeria. Lagos, Nigeria is actually Africa's most populated city with about 21 million people. It's the commercial hub of Nigeria. Currently it has over 500,000 houses for sale. In Lagos, everybody actually wants to be a homeowner. And this is an image of Ikoyi in Lagos. So there are two images on the screen right now. On the left is a semi-detached duplex, which for the Western audience can be called a townhouse. And on the right is a bungalow, which can be called a small family home. And these images were gotten from propertypro.ng, and they are all for sale. So now, what is decision trees? Decision trees is basically a set of decisioning rules, and these rules can be represented in an inverted tree. The rules are actually what make the decision, and each of these branches in this rule represents a decision. Decision trees is a type of supervised learning technique in machine learning and can be used for both classification and regression problems. The advantages of decision trees. Decision trees are actually quite easy to understand, to interpret, and also visualize for a non-technical audience. And they're very good at handling categorical data. And they also handle missing data quite well. The disadvantages of decision trees. You could actually grow over complex trees, and decision trees tend to have high variance. And this problem can lead to overfitting, although you could actually prune to solve the problem of overfitting. And these are some real-life applications of decision trees in the banking sector, the healthcare sector, the energy sector, even sentiment analysis. For this particular lecture, we'll be focusing on the housing sector. Components of decision trees. There are very important components you need to know while talking about decision trees. The root node, decision node, the leaf node, and also splitting. I'll start from the root node. The root node is actually the total data set. It's the main points that the decision tree would start from. All the data sets. It will be splitted into decision nodes or leaf nodes. Decision nodes are also nodes where decisions are made, but then they can be splitted further into decision nodes or leaf nodes. While the leaf node is the final decision. So when you get to the leaf node, it can no longer be splitted. And the concept splitting, it's actually the division of a particular node. So splitting can be done while at the root node or at the decision node, but you cannot split a leaf node. That's the final decision. How decision trees work. This shows a breakdown summary, if you would say, of how decision trees work. First, you start at the top of the tree, which is the root node. Then you grow it by splitting features based on conditions or decisions. And these decisions, you make decisions until it produces an outcome as a leaf node. That's the final decision. And at the bottom, you could prune the tree to prevent overfitting. Next is the feature or attribute selection measure. This basically selects the best splitting criterion that separates the data sets. And these techniques are both for classification and regression. You have the Gini index and information gain, which builds on entropy for classification. And you have reduction in variance, which is for regression problems. At this point, I want to make it clear that for this particular lecture, we would be using reduction in variance because we are doing a regression problem. And this image explains the whole concept of the decision tree. So it first starts at the data set, and because of this is a supervised classification, there will be a training data and also a test data. And for the training data, you use your ASM techniques such as reduction in variance because it is a regression problem to select the best criteria. And then this would be broken into smaller data sets, and this whole process will be done recursively. And after the model, has learned the whole process, it could be evaluated. And also at the end, you could actually check the performance measure using your R square, the mean square error, or the mean absolute error. Now let's go through this. The Gini index, basically a degree of probability of a particular variable being misclassified. For the Gini index, is the feature with the least Gini index that is being selected as the criteria for splitting. And that's the formula. Next is information gain. For information gain, after the data set is split on the feature, it decreases in entropy. And for the information gain, it finds the feature that returns the highest information gain. And that's what it uses for splitting. And that's also the formula for information gain. Next is the reduction in variance. And this is what we would be using today. Basically, the reduction in variance uses the standard formula of variance to choose the best splits. The formula, which is the summation of x minus x bar all squared all over the number of values, where x is the mean of the values, where x bar is the mean of the values, x itself are the actual data, and n is the number of values. This particular method uses the lowest variance as the criteria to split the data. Now let's go to pruning. Basically, most decision trees would actually be overfitted. Like we mentioned earlier, that's one problem of decision trees. So to reduce the level of overfitting, pruning comes into. Now you can actually prune branches which are considered having low importance. And pruning is very useful because these trees could actually overfit your training data, but they will not be able to generalize on new data sets. Basically, pruning is reducing the depth of the tree. Now, to solve the problem of pruning without using decision trees, you could actually use ensemble methods. Ensemble methods are basically built on the concept of decision trees. The first is the bargain. An example of bargain is random forest algorithm. And in this, it resamples training data repeatedly to build multiple decision trees. And the boosting method, these misclassified instances are given more importance. Now let's go to the live demo. From a live demo, the problem statement is to predict the price of a house based on various features in Lagos State. And I'll be making use of sklearn decision tree algorithm in Python. Like I mentioned earlier, this is a regression problem. So it's the regressor I'll be making use of. And the goals of the live demo, we would be going through exploratory data analysis, that's the EDA, and we're building our model. We'll be optimizing the model and also visualize the model. And this is the link to the collab. Okay. Now the agenda for this, like I said earlier, the data sets, the model building, optimization, and visualization. I am currently using Google Colab, and so most of the libraries are pre-installed. However, if you're using an IDE that doesn't have these libraries, you could always install them to be able to do the decision process. Now we're talking on Lagos datasets. Datasets was gotten from gg.com.ng, which is an e-commerce website in Lagos. And the datasets contains 1,000 records and also have 10 features. And these are all the features: the ID, the location, amenities, bedroom, and so on. The price is my dependent variable. I would also call it my targets variable. And the price is in millions of naira. So first off, I'll import my data sets. Now I will import my necessary libraries that I'll be using for the data sets. I'll use NumPy and Pandas. And I'll create a data frame from the data set. And data frame is called Lagos_DF. Now let's go to the EDA. This year explores the first five records. And this is the records. The location is in Aja. These are the specific location: Badore, Aja, Lagos. Location ID of Aja is 1. Amenities: the bedroom, the bathroom, the toilets, compartments, either bungalow or duplex, and the price. The price, like I said earlier, is in millions of naira. So 12.6 means 12.6 million naira. And my target variable is the price. ID here is just an index. And this shows the different data types. I have integers, objects, and the floats. The floats being my price. Now, this is just explores the data. 8,000 rows and 10 columns. These are the various columns. This is a summary statistics of this data set. And it shows me the different statistics of the numerical values of the data. Now I'm interested in the price. For the price, the maximum price is 73.5 million naira, and the minimum price is 3.1 million naira. Okay. And here I also check the unique locations of my data set. So we have Aja, Lekki, Ikeja, and Yaba. And for this particular stage, I'll be encoding the numeric categorical variables. What this means exactly is the data set shows location ID as 1, 2, 3, 4. Because of I have Aja, Lekki, Ikeja, and Yaba. But then with these numbers, we'd have to make the model understand that 2 is not greater than 1. There are more of rankings than actual numerical values. So they are categorizing the data not as numeric. So I have to encode this data. And I'll also be encoding the compartments, which is duplex and bungalow. And after doing that, I'll concatenate it back to the main Lagos DF. And this is the first 5 records. And I'll be dropping some columns. These are the only columns I need. Amenities, Aja, Ikeja, Lekki, Yaba, the bedroom, the bathroom, toilets, bungalow, duplex, and price. Remember, the price is my dependent variables. And that's because it is floating continuous data, it means it is a regression problem. And here I'll be splitting my independent and dependent variables. Independence here means features, and my dependence means targets. And these are my independence columns, and this is the price being my target. And here I'm creating an array of the variables. Now down to the second aspect, the model building. I would be using a decision tree regressor, and this is from sklearn. This is documentation from sklearn. And so here I'll be splitting my important libraries that I'll need. The first thing I want to do in the model building is model selection. And I'll be using the k-fold cross-validation. Let me explain this particular diagram. So using this is a diagram of a 5-fold cross-validation. And the concept here is, unlike the basic splitting of the training and the test data sets in most supervised machine learning work, this particular concept makes different folds of the entire data. For this, there are 5 different folds. And in each of the folds, it will select a particular part for the training and the remaining for the test. And for the next fold, the test data would be shifted, and the remaining parts would be for the training. And the next, it does the same thing. The next, it does the same thing until it completes the number of folds. So this can be done as much as the number of k. So the value of that k in the k fold, that's how much the data would be folded or splitted, trained and test. And for now, I'll instantiate the model using the default parameters. I would call my model DTReg, which means decision tree regressor. And this is the default parameters. The criterion is MSE. The max depth is none. maximum features none, and these are the default parameters for my decision tree regressor. And here I'll train the model on data sets using cross-validation. And for this, what I want to do is I want to score how good the model is based on the k-fold cross-validation I explained earlier. And so for this, using my cross-val score, one of the parameters is the model itself, the x, which is my independent variables, the y, which is my dependent variables, and a CV value of 5, which means I want it to do 5 different folds. And this would print the list of all the scores, and this is the mean of all the scores. And this is the results. If you can notice, at the second fold, it has a high score, 0.94, as compared to other folds. And the mean of this score is 0.87. Now, I also want to build a second model just to see how much, because definitely I'm doing my model selection in this part. So I can actually build multiple models and finalize them with the score and see which model would perform better and which model I would choose to train my data and also to test new data sets. And so with the new model, I'll just test and change some hyperparameters. So for here, I'm making the max leaf node a value of 40, the maximum depth a value of 8, and the random state a value of 40. And then this is the results from the cross-validation. Also still using a value of 5 for my folds. And so the second fold in this particular model also has a high score, and the total mean is 0.87. What this means is that 0.87 from the second model is higher than 0.85 from the first model. So definitely the second model would be a better choice because it scored slightly higher than the first model. Now, I also want to check for my hyperparameter using grid search CV. Generally, to reduce the variance, we can prune a model using these parameters in scaling: the max leaf nodes, the mean samples leaf, and the max depth. So for here, I'll import my libraries for validation, and I'll be using the grid search CV. I'll be performing a grid search on the parameter max leaf nodes. Remember, you could actually perform this grid search on various parameters just to check the best parameter that would get a better model for you at the end. So with this, I'll be using the default model. This first model I created had the default parameters. And per particular parameter I'll be looking for is the max leaf nodes. So with a range of 2 to 50, I want to check which particular value would make my model better. And the scoring would be the R-square score. And so the results of the best parameter, it says using the max leaf nodes with a value of 45. So with this, I'm confident that if I use this particular value for my max leaf nodes as a parameter in my decision tree regressor, it gets me a better predictor than if I just leave it as default. And so my DT final model would be using the max leaf nodes with a value of 45. Remember, you could actually choose the parameters using grid search CV on various parameters, not only the max leaf nodes. This is my DT final. I'll fit it into the X and the Y data, and I'll print the R² score after predicting, and it gives me a percentage of 96.5. What this means is, remember when we talked about reduction in variance in the slide? So your R² score basically checks for the predictive power of the model. So basically, R² score actually checks for the variability of price, of how price is being explained by the various features. So how your dependent variable is being explained by your dependence variables. And the remaining, let's say 3.5% is actually the residual. That is the part that cannot be explained by the features. And now I want to visualize the model. For visualization, I'll be using the graphics algorithm. In case you don't have this graphics algorithm, you could always install it in your IDE. And first, I'll be creating a dot data to visualize the decision tree model. Using my final model, and the feature names, the features which I had earlier. The class names is my targets, which is price. And here I'm rendering a housing Lagos.pdf file. And this is visualizing the PDF file. I'll open it in a different tab so you can see my tree. Okay. So this is the tree that the final model created. And from this tree, if I zoom in a little bit, so you can see the root node. It starts from the bedroom as the particular value that you choose. And this is the threshold, which is 4.5. The MSC is a particular splitting criterion that I choose. Then the samples is the total number of samples, which is 700. And the value is 25.052. And this particular root node was splitted into a bedroom less than or equal to 3.5 as the threshold, and also a toilet less than 5.5. And these are the different decision nodes. This is splitted continuously until it gets down to the final leaf nodes. This is an example of a final leaf node. All your final leaf nodes must end at an MSC score of 0. The reason why this doesn't end with 0 is because I made my maximum depth I fixed my maximum depth. But then if I leave it open, it might be prone to overfitting. And this is the total image. It's quite a complex tree. I could always go back and check for the different hyperparameters that could be changed, that could make my predictive model better. Okay, at this stage, I would go back to my slide. The key takeaways from this lecture. We talked about the housing price in general, and also talked about housing in Lagos. And then we talked about decision trees, advantages and disadvantages, and real life applications. And we moved on to components of decision trees. And we also talked about how decision trees work and how it splits, how it prunes. And then we did a small demo on Lagos housing data sets where we built a model. We did a model selection. We did hyperparameter tuning, and we also visualized the model. For additional resources on decision trees, you could actually read on any of this. And also the documentation for decision tree are also here, both the classifier and the regressor. Thank you very much. Are there any questions? Okay, I can see some questions. What house would I buy? Okay, for me, there are various factors that determine the price of the house. So definitely, I would build a model. With my current data set, I will make the model to help me predict on the type of house that fits my budget. Does each fold represent a regression step? So the k-folds in your k-fold cross validation, basically what it does is, instead of just doing one training and splitting, it does as much as the value of k. So it helps to really learn the data set. So it does it multiple times using various training data sets and various test data sets. So the k-fold one, the fold one won't use the same test data as the fold two. The same thing down to the highest number of k-folds. Oh yes, is the data set available freely? Oh yes, I would post the data set in my GitHub account. Okay, I see there are no more questions. At this point, I want to thank Ali. Ali has been very helpful all through the whole process in Delta Analytics. She has been patient with me. She has put me through various aspects in presenting and also the content of the work. She even taught me how to breathe. Thank you very much, Ali. And also, I also want to appreciate everybody in the first global teaching fellow cohort, from Krish all the way to Amanda, to Rao, to Dina, to Asida, to Sarah, to Leke, Somaya, David, Amanda. Thank you very much, everybody. And to contact me, you can contact me at chima.ibebunjoh@turntable.io, or you could check my GitHub account, Chima Coded, where I will also be uploading the Google Colab notebook, and also the data set. And also, you could watch this video on Delta Analytics ML Lecture YouTube channel, and also watch upcoming videos on machine learning. Thank you very much. What inspired you to join Delta Analytics? The first thing I noticed about Delta Analytics is machine learning for social good. So it doesn't make any sense if we as machine learning technicians or analysts or scientists to actually only use this new technology, I'll call it new, to actually just benefit an aspect of the world without doing good with it. And so Delta Analytics had this particular vision of using machine learning or artificial intelligence as a whole for social good. And that's what encouraged me to join Delta Analytics. What is your favorite learning from the time with Delta? Totally, I've learned so much from Delta Analytics, both the Bay Area various fellows and the other global fellows. But in particular, I've learned actually how to teach coding. So it's quite hard to do a live demo, whereas it's done remotely. It could be quite easy while you're doing it in the same room with your students, but remotely it's quite hard. And so using the pruning technique, I've learned a lot on how to code or teach code to people. Thank you, Asida. Thank you, Dina. Thank you, Rao. Brian, thank you. Thank you, Peter. Thank you, Delta Shadow.
Okay, that concludes our talk. Thanks very much, Chima.
Thank you,
And
Ali.
hope everyone enjoyed learning about decision trees.